This is a chapter 4 review. In that graph, there was, in the short run, in the beginning of that graph, there was a lot of variability, right, up and down quite a bit. In the long run, though, it evens out to be the true probability of what that player shoots. Okay, and number 2, you can either, to find the missing one, you can either, you basically have to add up all the ones that they have and subtract it from 1, or you can take 1 minus each of them individually, but your answer for that one that's missing is 0.218. So you know all of them have to add up to be a probability of 1. Okay, so letter B, when they ask you for the not begin between those hours, so you can either add all the ones that did not add between those hours, or take 1 minus the ones that did between those hours. So either way works there. 0.766 is your answer. The one here at the bottom, what's the probability that randomly chosen began between 6 and 9, almost 10 o'clock? You can either add all the ones that fit this, or take 1 minus the ones that don't fit in that. Okay, so both ways work. So 0.927. Number 3. Okay, so find the probability of H. H is defined as hatching. So hatching, if you add up all the hatching, was 129 that hatched out of a total of 187. So it'd be helpful to maybe get all your totals when you first set that up. That might be helpful. Okay, part B, not cold water and hatched. Okay, so not cold and hatched. So you think about which ones hatched and which ones are not cold. So that'd be the neutral plus the hot. So the neutral 38 plus the 75 give you the 113 out of the total 187. Part C, probability of hatched complement. Okay, complement means not. So hatched, so to complement of hatched is not hatched. So probability of not hatched or cold. Okay, so not hatched or cold would be the 16 plus the 11 plus the 18, or the 20 and the 27 added together, give you the 74 out of the 187. Okay, the next one here, you're thinking about the discs. Okay, so making a table here first. So our two events are either it's blue or not blue, and the other two event is either 8 or not an 8. And you can fill in, there's only one blue 8, there's 3 others of the 8s of the other colors, right, or 8s, for a total of 4 of those 8s, and etc. Okay, you know, in blue there's 9 numbers total, one of them is an 8, 8 of them is not an 8. Okay, so you can think about that, how you set that up. Okay, next one, probability of B that it's blue. Blue would be 9 out of the 36. Probability that's an 8. Okay, 8s, there were 4 8s out of the 36. A blue and an 8 would just be that one disc that's a blue and an 8. And why can't I just add them together? Okay, why can't it just be the blue plus 8? Okay, because if I add these two together, that'd be the 9 and the 9 and the 4, right? If I add these together and I add those together, I'm overlapping this one. So remember, our OR formula is probability of B plus the probability of E minus their overlap, probability of B and E. Okay. Number 5, going back to that hot cold one, I maybe should have switched those two around, but yeah, well. Okay, so probability of hatched, given that it was in hot water. Okay, so it says they were given that it was in hot water. So hot water, if you add those two together, the hot waters, there are 104, the 75 plus the 29. Okay, those are the ones that were in hot. Now out of those hot ones, how many were hatched? 75 out of the 104 hot ones were hatched. Okay, we're part B. We're looking at all the ones that were hatched, so add up all the ones that were hatched. The 16 plus the 38 plus the 75 gives you 129 that hatched. And how many of them were not in the hot, right? Hot complement, not in the hot. So not in the hot would be the 16 plus the 38, which would be 54 out of the 129. With number 6, they ask if being female and being right-handed in this information they give you is independent. So remember, if it's independent, it means that one event does not affect the other event. Okay? So the probability of some being female should be the same as if they're female given that they're right-handed. So of all the right-handed people, the proportion of females that are right-handed should be the same as just overall females. So the probability to select a female was 21 out of the 28 people. And out of the right-handed people, out of the 24 people that were right-handed, there were 18 of them that were females. Okay, give you both the same percentages, therefore yes, they are independent. Okay, now you could have also done it a little bit differently. You could have switched those two variables around. So the probability that somebody's right-handed is equal to the probability they're right-handed given that they're female. So right-handed people were 24 out of the 28, and the females that were right, okay, out of the 21 females, there were 18 of them that were right-handed, which give you the same percentages. So yes, they are independent. Okay, number 7, a little tougher. You had to set up a tree diagram to make it really make sense. Okay, so 25% of the objects that it passes over are metal, which means 75% are not metal. Of the metal objects, it identifies and it picks up 98% of them, which means it doesn't get 2% of them. Of the things that are not metal, it still picks up and identifies 4% of them, but not 96% of them, which a metal detector you wouldn't expect to. Okay, so if you multiply these together, multiply the different outcomes, okay, this is the percentage of overall outcomes. If you add those together, you get a probability of 1, right? Those are all your possible outcomes. Now, it says, what's the probability that he, when he gets something, that it's going to be metal? So 1, it has to be identified, okay, of all things that he identifies that the metal detector picks up, what percent of them are metal? So of the ones that are identified, so it identifies these objects and identifies these objects. So if I add those together, it identifies 0.275 of the objects. And of those objects, how many are metal? So it'll be this percentage out of that percentage which are metal. Which means when he finds something, there's a probability of 0.89 that it is a metal object.